PRT 563. The presentation is about relational database creation for BDO Darwin. Our group members, including myself, Muntasir, Tasfia, and Zunayat. So the content of this presentation is, first we will give a little background to our company selected and the project scope, then UML diagram, then EER diagram. After that, database creation in SQLite and SQL queries. Finally, 3NF and custom Python script. The company that we selected is BDO Darwin, which is an audit firm in Darwin City. The contact person is Kasmal Thasiva. He's the audit partner. So we discussed with him about the database available there. So he explained that the project management function is lack of centralized database. So the current data is managed through annual work plan, which is an Excel document, which is not sufficient. So the relational database will help partner to make strategic decisions by monitoring the data inside, and as well as it will ensure employees to achieve their project on time. So we have identified few data tables that available with BDO. That is employee table, which has employee information, then the employee rate table, which has the hourly rates, and then work hour table, that is how many hours that employees budgeted and what is the actual hours they worked on. Then the client table, which has all client information. The other table is work order table. Each work is start with a work order. So work order has all the details, including approvals. Then the project table, it has the project start and end dates and the actual period that the project has been covered and which employees were engaged in. Then finally, the billing table, which has the amount billed and amount due. Next, Muntasir will explain about ER diagram. Thank you.
Hi, this is Muntasir. Now, moving on to the next piece of our presentation, we have the UML class diagram, which essentially brings a different perspective, focusing on the structure and behavior of the system. The UML class diagram dives deeper into the operations and attributes associated with these entities. So let's just start by looking at the employee class. Here we can see that just like we will see in the ER diagram, employees have attributes such as first name, last name, job title, and experience. However, in the UML diagram, we also introduce functionality methods that allows us to create, read, update, and delete employee records. This shift towards behavior shows how employees interact with the system, not just as data points, but as objects that perform actions like processing billing and managing work orders. Secondly, the work order class also draws heavily from the structure, and which will be discussed in the ER. In addition to attributes like hours ordered, estimated bill, and approved status, the UML diagram introduces methods to create, update, retrieve, and delete work orders. This reflects the operational aspects of the system, allowing you to manage work orders dynamically based on the needs of the businesses. Last but not the least, the UML diagram also formalizes interactions with client base and billing classes, allowing you to create clients, manage their details, and handling billing effortlessly. Also define methods that ensures data consistency and operational efficiency. These methods align directly with the relationships and flows that will be discussed in the ER diagram, showing how the system handles data flows across various operations from retrieving client orders to generating bills. To conclude, what the UML brings to the table is a clear picture of how these elements work together to provide a dynamic functioning system that not only tracks information but also drives the core operations of the businesses. Now, Tash will cover the rest.
Alrighty, so let's dive into the enhanced entity relationship diagram. Here at the core of this model, we can see that we have the employee entity, which is defined by attributes like employee ID, first name, and so on. So the employees here are linked to their work hours through the employee hours relationship on the left, which tracks the key metrics such as annual hours target, overtime, employee work hours rate. This ensures that the system not only manages employee information but also integrates dynamic work calculations, enabling BDO Darwin to handle regular and overtime rates with precision. Now, moving on to the client-based entity on the right, this is where all the client-related information and data is stored, including client ID and client name. Each client is associated with multiple work orders, which are tracked through many-to-one relationship. The work order entity contains crucial details like WOID, estimated bill, approved status, and work order. So these work orders are then associated with the specific projects, ensuring that there's a seamless flow of information from client request to client execution. Finally, we have the billing process on the bottom. So the billing process is fully integrated within this structure. Each work order feeds directly into the billing entity, which captures amounts due, amounts paid, and total bill. So the system is basically built to process billing data efficiently by linking employee work hours, project data, and client specific work orders. And moving on to the next slide, where we have our relationship schema, which is basically the backbone for building our database and implementing our database. It shows how key entities like employees, work orders, clients, projects, and billing are interconnected, and those are the ones which are highlighted or bolded. Each relationship is defined by unique identifiers, and this ensures that there is an efficient data management and smooth integration of these various processes. Handing over to Zunaid.
So based on those relationship schema, we started at building our database on the SQLite. We created the SQLite 3 database, and on those we have started with the most parent tables, and in these we have created the tables, have identified what are going to be the columns and what type of data is going to be there, and then slowly moved on to the dependent tables such as work orders, and then like client orders, client base, such as such. And we've also like addresses like the primary key and the foreign key in there, so that like it creates like the proper database and then doesn't fall out while we run the queries. Once that is done, we wanted to put in sample data as it's audit firm and it has highly confidential data. We used random sample sets, and we created we put in like 5 rows of data in each tables. And yeah, we started with the parent table, which is the employee. We started with those and slowly moved on to the billing tables, work order, and client base, which are highly dependent on the other tables, and there are like data in there. And just to check whether our relationship database is working or not, I created these queries to get detailed of a project billing informations for all the project that is handled by a manager, which should be coming from the employee table positions. And also it includes our order, total bills, and amount due. I've run it on my SQLite. As you can see, it shows the result as well. And the next part is where we took an approach to create a normalization process, because as there are different type of data coming in and pushing into the database, we needed to create a system that identifies the transitive dependencies or ensure atomic values. So we created this Python script, which is basically connects with the database in the local repository, and then checks on all the tables that exist and connect push those tables into Panda framework. After that, it's much easier to process the 3NF. So for the time being, what data and tables we have, we identified these are the issues that have. And for example, the project has composite key columns, it has transitive dependencies. So we have addresses those issues. We have separated the columns into their own tables, and again, push those completely merge those columns again after normalizing and push those back into the data set, and it closes the data loop. So as we move on, like creating more tables and more data into the database, this need to be changed as well, because like the more tables and more data might have different issues. But for the time being, we identified these are the problems and we address this here through this Python script. And I've run this on my end, and as you can see, it worked successfully, and it populated the table successfully again. And for the lastly, the conclusion and further scope, we have created a very centralized relational database, which the BDO can use to put into their data, and it also helps to normalize the data, and also helps to see what are the projects going on, who is working on what. But yeah, there's a further scope to it, as we wanted to move this to this relational database to a NoSQL database with Neo4j, and we wanted to implement graph database modeling and implementations, and so on, centrality and similarity algorithm as well. And another aspect is that we had these conversations with the client that we want to use the human resource efficiently. So we will touch on that aspect in our next project as well. For the time being, that's all from us. Thank you.